Hi guys, so today we're doing vertical projectile graph types problems, and you're more than welcome to pause the video and attempt the problems on your own. Let's begin. Right, so we've got Q4 and 4.1. Let's read the question statement. The ball is released from a certain height, so it's not dropped. You don't know the V initial. Alright, good. The velocity time graph below represents the motion of the ball as it bounces. Oh, it bounces off vertically on a concrete floor. The interaction time of the ball with the ground is negligibly small and is thus ignored. Okay, good. Now, 4.1. Describe the changes, if any, in velocity and acceleration of the ball from t0 and t 0.4. Now, one thing we have to firstly look at is which direction was taken. Is up positive or down negative or what? Right? Now that is the first thing that we have to assume to firstly identify, is up positive or down negative. Now from the assumption we can, this is just assumptions, we're going to prove it, by the way. I can be wrong, you can be wrong, this is just assumptions. Now since the V initial is 0, this means it is dropped and then it went up. The velocity goes up. So if the velocity is going up and then it bounces, alright, so this means that the downwards was taken as positive due to this. Downwards was taken as positive because it went up. You can even check using the using the acceleration. So say 0, find the gradient of this, 0 minus 4, um, yeah, divided by 0.2, of which you should get at least a close enough answer. But then, yeah, that's just an assumption. So if we are asked to calculate, I'll give you the correct direction. Good. Now let's continue. So it is released from a certain height. Oh, it is released from a certain height. I thought like, oh, okay, it's fine. Good. So let's describe the changes in velocity and what. So the time it's 0 seconds. So at 0 seconds, what can be said? At 0 seconds, the ball starts from rest. So the ball, t 0 seconds, the ball starts at rest, right? So this is when the ball starts, right? And at t 0.4, t 0.4, let's see, t 0.4, it follows at a constant acceleration, you know? So yeah, falls at a constant acceleration. Now they said they wanted in velocity and acceleration. So velocity is this one, acceleration is this one. And then yeah, simple. Just like that. You're done. You're done with 4.1. This is basically what they wanted only. Now for 4.2, without using equations of motions. Ooh, now this is why basically it is not even important to know the direction at which this ball is moving. I mean, like, it is not important for you to know if up was taken as positive or down was taken as negative because of this question. Calculate the height from which the ball has been dropped initially, right? Now, if let's say you were to use the equations of motions, you'd need to find the acceleration of this, right? Now, the acceleration, this is what you would do basically. You would say 0. You would say 0. You would say 4. Let me do this. 4 minus 0 divided it by 0.4 minus 0. And then yeah, this is how you'd find your acceleration, since acceleration is defined by the change in y divided by the change in t. Right, then yeah, since it's positive, this means downwards was taken as positive, as I said in the beginning. Good. So without using the equations of motions, now what are you going to do? Basically, all that you need to know is what do they want? Calculate the height from which the ball has been dropped initially. So the ball is dropped there. Okay. So if it's been dropped at this point, they want the what? The height. The height, it's the area of the shape. This is the height. It's the area of the shape. It's the height and the breadth. Basically, change in y, it's equals to 1 over 2 bh. So I'm going to say 1 over 2, 0.4 times it by 4, and my answer is what? 0.8 meters. Good. Then you're done. This is basically your 4 marks because number 1, you were able to identify the shape. Number 2, you know that the area under the graph is what? Is the height. Describes the height. So, yeah. Oh no, sorry. Now for 4.3, copy the set of x's into your answer book. Okay, use the given a velocity time graph for the motion of the ball to sketch the corresponding position graph for the time interval from 0 seconds to 0.7 seconds. Okay, so they want us to basically draw. So here's what we're gonna do. So it's gonna be 0, 0.2, 0.4, and 0.6, 0.7. It's just the way that you do it. Right, so alright, now since this ball was basically dropped at a certain height, we know that the graph is going to be like this. Firstly, let's look at the point 0.4. What is happening at 0.4? It's when it bounces, right? Okay, so if this is where it bounces, you start here. The position is at 0 because the ball it hasn't been dropped. Then it goes down. At 0.4, it reaches the ground. Then at 0.4, it does what? It bounces. After it bounces, it goes where? To the side. So this is how you'd basically draw it. You just had to be take note of this. This is important. Okay. This is important, this point here, because you have to know, okay, this is when it bounces. Then this height here, it's the total height that we found, which is what? 0.8. So you can just write 0.8 here. Then it went down and then touched the ground. Basically just showed us what was happening and how it was dropped, the position time graph. Right, moving on to 4.4. Is the first collision of the ball with the floor elastic or inelastic? Give a reason for your answer. Now for this one, it won't take you enough. It won't take you time because just look at the speed at which this ball lost. So look at we should check this one first, right? Look at 4 meters per second. Its VF when it touched the ground was 4 meters per second. Then it went up with an initial velocity of what? Of 3, maybe 3 or 3.2 or something, but it wasn't 4. So basically energy was lost during the contact time with the ground. So with that said, you can just say it was what? Inelastic. Inelastic collision. Right. Collision. Why? Because there was a decrease in what? Decrease in speed, right? And it went from 4 meters per second to what? To, let's just say, I don't know. You can choose any number you want, but I'm just going to take 3, right? But don't say 4 to 3 meters per second. Right. So that's how you answer this one. Or you could just say there was a change in the kinetic energy during the collision. That also works out. So guys, hope that you enjoyed this video. This was a vertical projectile graph type problem, and if you have any more questions, please leave them in the comments or email me